Well done, boys. Looks like ice cold sushi for breakfast.
Hello everyone! We're from SS3 Nara
of San Roque National High School. I'm Nita May S. Bolaño.
and Daniela Camaya. We will present a short video about the magic
Behind
physics!
Oh, Chester, what do we have there?
It's Ninfa. I am Chester G. Garcia,
And I'm Laika Bendibil.
and we are here to discuss what free fall is.
Free fall or falling body. The objects fall freely because it is pulled by a gravitational force. When the object is falling down, it increases its speed.
The object increases its speed when it's falling down with the help of gravity. And remember that gravity is equal to 9.8 meter per second squared. And we have 6 main equations to find the velocity and distance of falling bodies. And that will discussed by our two beautiful ladies, Miss Russell Santiago and Elisa Pichua.
That's true, Chester. We are beautiful. I'm Russell Santiago.
And I am Alisa Chua.
We are here to tackle the sixth equation to find the velocity and the distance of a falling bodies. First, we discuss the three equations with initial velocity Vf, final velocity, Vi, initial velocity, G, gravity, and T for time. To find the velocity of falling bodies, Vf equals Vi plus Gt. To find the distance of a falling bodies, D equals Vit plus 1/2 Gt. To find the velocity of a falling bodies, Vf equals square root of Vi squared plus 2Gt.
And here's the three last equations without initial velocity. Vf is equals to gt, d is equals to 1/2 gt squared, and Vf is equals to square root of 2ad. Thank you.
Hello again guys, we are here to perform a short example and problem for us to be able to understand what free fall is.
Hello again guys, I'm your demonstrator for today that will demonstrate free fall. If I drop this ball from this place to the ground, the total time required is 1.7 seconds. The problem is, how long is the distance from this place to the ground? And what velocity will take the ball to the ground?
So okay, for another example, Ms. Ria Maglake will demonstrate us.
Hi there, I'm Ria Maglake, and I'm here to give a problem to solve the final velocity of free fall. I have here a ball. I drop it on the ground with its initial velocity of 17.22 meters per second and it has a required time of 22 seconds. Now, the question is, what is the final velocity of the ball?
Okay, here is the solutions for the given problem. Given time is equal to 1.7 seconds and the gravity 9.8 meter per second squared, and we need to find the final velocity and the distance. Okay, let's start with the final velocity. The formula for finding the final velocity is gravity multiplied by the time. So final velocity is equal to 9.8 meter per second squared and 1 multiplied to 1.7 seconds. The second squared will be cancelled because of the second, so that it will become second. So the answer is 16.66 meter per second. And let's go to the distance. 1/2 gt squared, distance equals 1/2, 9.8 meter per second squared multiplied by 1 second squared. The squared of 1.7 seconds is 2.89 seconds squared, which is going to multiply to 9.8 meter per second squared. So the answer will become 28.32 meters multiplied by 1/2, and the final answer is 14.16 meters.
After we discuss the free fall, now let's move on to another topic,
Which is law of motion.
also referred as law of inertia. Wait, Ninfa, what is law of inertia? Do you know it?
We better ask Chester and Laika.
What a brilliant idea.
Yes guys, we know that. That's why we are here to discuss and explain what is law of inertia.
Law of inertia states that a body at rest will remain at rest and a body in motion will continue moving unless acted upon by external force.
So guys, let's have an example. The small baby carriage has very little resistance to changes in motion. Since the baby carriage is small, it is very easy to change its speed or direction. A small net force is required to change its speed or direction. So now we prepared an actual example for law of inertia. And that example will demonstrate by Giancarlo de la Cruz.
Okay, viewers, let's go. In law of inertia, it states that a body at rest will remain at rest, and a body in motion will continue moving unless acted upon by external force. But in this situation, the body is at rest. But if I kick it, it moves. Ria Maglake will explain how the ball moves and how the ball stops.
Okay, here's the reason why the ball stops. Since the ball is small, it's easily to stop when it's moving. A small net force is required to change its speed.
So guys, I'm here for additional explanation why the ball stops. It can cause also the surface. If we've seen now the surface is rough so that it has a friction. And in this place there is an air so that it can also cause why the ball is stopped.
Very well said, Chester and his group. Now we know what is law of inertia.
Now, let's move on to the last but not the least second law of motion, which is acceleration.
After the two topics that we discussed, now we are going to discuss and explain what is the last topic, and that is the law of acceleration.
Law of acceleration is directly proportional to the net force acting on the body and inversely proportional to its mass. Its direction follows the direction of the net force.
So now Russell will give an example.
One of the example of law acceleration is moving of a car. When the gas pedal is pressed, the car is moving forward as accelerating. When the brakes are passed, the car is decelerating.
To find the force of acceleration, we have a formula of F is equals to mass times acceleration.
Okay, we have a problem here. The question is, what force is required to accelerate a 3-kilogram object at 5 meters per second? Russell Santiago will solve this problem. So, like what Alisa said, the formula for finding the force is force equals to mass multiplied by acceleration. So, can I have the chalk? Okay. The given mass is 3 kilogram. And the given acceleration is 5 meter per second. So that we are going to multiply the given to find the acceleration. 3 kilogram times 5 meter per second is equal to 50 Newton. Why Newton? Newton is the sign for force. So, we prepared a video or example for us to understand more about law of acceleration.
Hello again, everyone. I'm here, the demonstrator will demonstrate how does acceleration produce in this good and simple example. You see now, I'm pulling this huge table. Now viewers, the problem is, what is the acceleration or how does acceleration produce in this given problem? How does the acceleration affect the force of this table. Miss Ria Maglake will explain all of the problems.
Pulling cable across the floor would also be another example. The law of acceleration is a depiction where the force is applied to the table to move it forward or to accelerate it.
Hello guys! Thanks for watching our video and hope you learned something from us.